Hi everyone, this is GPY 100, Physical and Environmental Geography. We are moving to the second half of this semester where we will talk about the hydrosphere, the biosphere, the pedosphere, the sphere of soils, and finally the lithosphere, the sphere of rocks. So this week we are covering chapter 9 and this is our introduction to the hydrosphere. The hydrosphere is the sphere of water. About 71% of the Earth's surface is covered with water. Most of it, of course, are global oceans. Scientists estimate that the hydrosphere contains about 1.36 billion cubic kilometers of water. And water is a major constituent of almost all life forms, including humans. Most animals and plants, and of course us as well, contain more than 60% water by volume. The Earth is indeed a very watery place. About 71% of the Earth's surface is covered by water, and the oceans hold about 96.5% of all Earth's water. Water also exists in the air, in the atmosphere as water vapor. You know that about between 0 and 4% of the atmosphere can be actually in the form of water vapor. It is also present in the hydrosphere itself, in rivers and lakes, in ice caps, in glaciers. It is also present in the lithosphere, in the groundwater and in the soil moisture and in the aquifers. And of course, it is also present in the biosphere in all organisms, including humans. The atomic structure of a water molecule consists of two hydrogen atoms joined to one oxygen atom. There are three patterns of molecular arrangements in water when it changes its physical state from ice to water to gas. Ordered molecular structure is present in ice or frozen water. Semi-ordered molecular structure is present in liquid water, and random molecular structure is typical for vaporized water or water vapor. All water on our planet can be stored in any one of the following reservoirs. They include the atmosphere, oceans, lakes, rivers, soils, glaciers, snowfields, and groundwater. Water constantly moves from one reservoir to another by way of processes such as evaporation, condensation, precipitation, deposition, runoff, infiltration, sublimation, transpiration, melting, and groundwater flow. This picture of hydrologic cycle, which is also available in our textbook, shows us the movement of water from one reservoir to another through this variety of different processes. On your own, please watch a video, the hydrologic cycle, which is available on the Blackboard in the folder videos. And also on your own, please watch the video on the hydrological cycle available on Mastering Geography. Those are two different videos, even though they have the same title. Water is constantly cycled between all these different reservoirs, and as it's cycling between the atmosphere and the hydrosphere and the biosphere and soils and cryosphere, the sphere of ice, it stays there for very different amount of time. So, for example, on average, water can be renewed in our rivers about every 16 days. On the other hand, water in the atmosphere can be completely replaced through the water cycle approximately every 8 days. In some of those reservoirs or some of those hydrological sinks, water can actually stay much, much longer. For example, water in the ocean bodies, even though it's moving, but it remains in the same reservoir for a long period of time. Water can be locked for hundreds or even thousands of years in the mountain glaciers or in the polar ice caps, and it can be also staying for a very long time in the form of the groundwater when it is stored in the aquifers. So we might be using right now water that has been actually accumulating for millions of years in mountain glaciers or in the ice caps or in the form of groundwater in the aquifers. This table gives you a breakdown of how much water by volume and percentage is actually available in all these different reservoirs. And you can see that by far, most of our water, 97.25% of all water on Earth, in the oceans. This is salty water. We cannot use it without desalinization, and this desalinization takes huge amount of energy. So water which is actually usable for humans is primarily in the ice caps and groundwater and lakes and soil and streams and rivers. So that amount is not that big, and by far the largest reservoirs of this water is in ice caps and glaciers. And so unfortunately, because of global warming, because of anthropogenic climate change, we are losing now considerable amount of this water that has been stored in the glaciers for millions of years, and it's going into the oceans where it's mixing with salty water. Groundwater, which is also one of our primary resources of fresh water, is approximately 0.68%, and then all other reservoirs are really small, such as about 0.01% is in lakes, and it's even less in soil moisture and in the streams and rivers, and a very tiny amount of it in the biosphere. So it looks like we have lots of water, but actually we have only 2.75% of this water is actually available for human use as fresh water. So as I mentioned already, oceans cover about 71% of the surface of our planet, and this is 360 million square kilometers of the surface of the Earth. On average, the depth of world's ocean is about 3.9 kilometers, and maximum depth, however, can exceed, in Mariana Trench, 11 kilometers. The ocean contains 97% of our planet-free water, but of course, this water cannot be used without desalinization. And here are all our oceans: the Pacific, the Atlantic, the Indian Ocean, and the Arctic Ocean. So over 97% of the hydrosphere is actually made of salty water, water of the oceans. And it's salty because of the presence of natrium and chloride and other compounds. In fact, only 6 elements and compounds comprise about 99% of sea salt, and those are chlorine, sodium, sulfur, magnesium, calcium, and potassium. The second major reservoir of water, and this is fresh water, that comprises about 2.05% of the entire hydrosphere, is permanent ice, and permanent ice includes ice on land, such as mountain glaciers, ice sheets, ice caps in the Arctic and the Antarctic, as well as ice floating in the ocean, such as ice pack, ice shelf, ice fall, and icebergs. So this is fresh water, and again, as it melts due to growing temperatures, due to climate change, we are actually losing this permanent ice, which is going into salty ocean. Some other really small reservoirs include surface water such as lakes, rivers, streams, swamps, marshes. Surface water only comprises 0.02% of all water on Earth's system. So it's really small compared to the ocean and even compared to glaciers. Another water reservoir, which is actually very important for us humans, is subsurface water. And subsurface water includes groundwater and soil water. And together they comprise approximately half of the percent of all water in the hydrosphere. So it's quite substantial. Water beneath the surface can essentially be divided into 3 zones. It's the soil water zone, it's an intermediate zone, and then the groundwater zone. Most of the subsurface water is associated with groundwater. Groundwater occupies the zone of saturation, and the water table separates the zone of saturation from the zone of aeration. So zone of aeration is on top, and then zone of saturation is at the bottom here. Groundwater is found in aquifers, and those are bodies of earth material that have the ability to hold and transmit water. For example, sand can hold quite substantial amount of water. And these aquifers holding water can be confined or unconfined. Unconfined or open aquifers are connected to the surface above, and so this is where we would see a spring or a source water flowing from the surface of the land. Confined or closed aquifers are sandwiched, they're essentially squeezed between dense impermeable layers on Earth. materials that are called aquicludes. For example, a layer of sand can be squeezed between two layers of clay that are impermeable, and so water would be sort of locked in that layer between two aquicludes. Groundwater is replenished by percolation of water from the zone of aeration downward due to gravity to the zone of saturation, or in the recharge zone of the confined aquifer. The recharge zone is where the confined aquifer is exposed at the surface and then water can enter in. When groundwater is confined, like here, between the two impermeable layers, this type of enclosed water is called artesian water. A confined aquifer can produce a pressurized ground-to-surface flow of water, which is known as artesian well. So even though it looks like we have huge amount of water in the hydrosphere, only a very small portion of it is actually available for human consumption. And we are also literally running out of water as we're using it for not just only for drinking, but also for irrigation, for our industrial purposes, for agriculture, for washing our clothes, for cleaning ourselves, and so on. So this is how much water we actually used based on the data from the EPA, Environmental Protection Agency. It's really disheartening to think that 24% of water here in the United States is actually used for toilet flushing. And our showers are taking about 20%, faucets take about 19%, our washers 17%, and we are wasting lots of water just because of the leakages. So 12% of water is simply lost because it leaks. If we compare water consumption around the world, we obviously, in the United States, we are consuming unprecedented amount of water, way more than it's really necessary. Our average per person consumption in the United States is 156 gallons a day, and it's not really necessary. We obviously can use technology to do much better and save water by using better technology in our toilets and faucets and showers and car washes and so on. So it's not going to create deprivation even if we could cut our water consumption by half. In fact, average person in France, where the quality of life is also very high, is consuming about half of what is consumed in the United States, 77 gallons a day. And to compare, an average person in India is consuming only 38 gallons a day, and an average person in Mali, which is of course a very dry desert country in Africa, is actually consuming only 3 gallons a day. So I'm going to leave you today just with those numbers to think about. And as always, please remember about the quiz, which is due this Friday. And I will see you next week. If you have any questions, please show up during the tutorial online or send me your questions by email.